All the sides will be the same.
So this is 18 inches and this is 18 inches, right? Martyr, what's happening in this problem? How are we making this pizza box?
They don't have a top.
It doesn't have a top, but how do they make the pizza box? What are they doing? They're cutting corners, right? They're cutting this corner out, this corner out, this corner out, this corner out, and then what?
Making it a box.
Right? So like, pow, cut out the corners, see? So clever.
Yeah.
So now this is what we're looking at. How do they make the box? They fold. They fold it up. They fold this side in, this side in, this side down, and that's what makes the box. Are we okay? So for a lot of you guys, I saw you're like, all right, I've got a box. So I've got my box now looks like this. And I saw a lot of folks that told me what the objective function was. What's the objective function? What are we trying to optimize? What are we trying to make really big or really small?
The volume.
We want to make the volume really big. So my volume, right, I picked a nice friendly shape. You guys know that volume is length times width times height. Now here's where the geometry is going to get tricky. How long is the box? How wide? How tall?
That's what we're looking for.
Now the box starts off 18 inches by 18 inches. But what happens is I cut out those little corners. And I don't know how big the corners are, but I know that they're squares. So if what you want to do is, let's call this guy over here X, then this guy over here has to be X. That's the only way that when they fold, they're going to meet, right? They have to be the same length. So this guy here is X by X. This guy here is X by X. X by X. X by X. X by X. So my question, have a quick conversation. How long is this new box?
18 over X.
18 minus 2. 18 minus 2.
Wait, no, 18 over X. No, 18 over X is...
Think about one side.
You're taking out 2 x's.
Yeah.
18 minus
Okay, so I've heard 18 minus X, 18 minus 2X, and 18 minus 4X.
18 minus 2.
How many guys for 18 minus 4X? Not even Jennifer anymore. How many guys for 18 minus 2X? Anthony, why 18 minus 2X? I'm taking out an X over here and I'm taking out an X over here. So that means that the length of my new box is 18 minus 2X. The width?
18 minus 2?
Same, 18 minus 2X, and how tall?
18. No, I don't know. X.
Same.
X.
18 minus 2X, 18 minus 2X. This X piece is the part that you're removing so that you can fold up the box. When you fold that up, how tall is the box? That's what the X is for. So that's that. So your objective function is going to be 18 minus 2X times 18 minus 2X times X. With these optimization problems, it is always the geometry that kind of puts like a big bar in front of you in the beginning. I bet most of you know exactly what to do from here. How many guys are feeling pretty good with what you're going to do? Okay, talk to somebody near you. What's your process? And get going.
That's the objective. That's the volume. That's right. Yeah, right, that's right.
What's the constraint?
What's the constraint? Good question.
So it's not 18 times equals L times W.
So the constraint is normally the equation that tells you how the variables have to work together. Like that hypotenuse question, it was like x was this way and y was this way. It said x squared plus y squared equals 5 squared. So whatever I did with the x and the y, it had to satisfy that relationship. Is there a constraint?
18 squared?
There's not another variable.
There's not another variable. You already have your objective function in one variable, so guess what?
Find the derivative of that.
I can find the derivative of this. The reason that we worry about the constraint and all those other problems has been there's been 2 variables and we needed to get rid of one. There's 1 variable.
324.
Okay.
Okay, I don't know how many of you guys overheard the conversation we had up here.
No.
There is no constraint in this problem. There's no need for a constraint because my objective function is all in one variable. So if my objective function is all in one variable, what's your next move, Abraham? What are you going to do?
Find the derivative.
You're going to find the derivative and then
Set it
set it equal to 0 and do all your stuff. Okay? Yeah.
I have a question. Just like, if we're trying to, we know we're trying to maximize our volume,
Yep.
and we know that it's base times width times height.
Yep.
So can't we just say by, and if, okay, no, never mind. I'm gonna see how the end of this problem is. Then I'm gonna
There you go. Yeah, don't just jump to the end of the story. Everybody okay? We get the volume. I want to find a derivative. Options for finding the derivative here. I see at least 3 different options. Adriana, what's one way?
You can use a product rule to
You-
find the derivative.
Love it. I could do a product rule. Other options. What else? What else? Jennifer, what else?
You can turn 18 minus 2x into 18 minus 2x squared and find the volume.
I could write this as 18 minus 2x, the whole thing squared, and then times x, and then it's still product rule like a chain rule. What else? There's a third option here. There's a third option. Noemi,
Distribute?
what if you just multiply all that stuff out
Yup.
and then take a derivative? Is that okay?
Yup.
Okay, in fact, I wanna push you guys in that direction, just so we can all have a common derivative that we're looking at. So 18 minus 2x, the downside with this one, the numbers are a little bit ugly. 18 times 18, 324, negative 36x, negative 36x, 4x squared.
Yeah.
So 324 minus 72x plus 4x squared times x is going to be 324x, 72x squared, 4x cubed. Whatever, it just, a little bit of algebra, some ugly numbers. So, go find the derivative. Go do your stuff. I want to check in with some folks on some things. All right, friends over here. David, you told me, oh no, I don't know grade goal for you. A grade goal, I'll pass this around yesterday. If you stayed 74 or higher, you get a C6. Okay, so we're gonna go with 74. And Monday is your, Anthony, get 77. So Thursday.
Am I saying something?
And so Monday, but not Thursday. Okay, works for me. Yes. Get 87 as your grade
But I
level,
don't know.
and you don't have a mandatory day.
Five zeros, right?
Abraham, 75 is the goal. And Thursdays is your day, right?
What if I could change it?
Negative 324.
I was thinking like, let's say next Tuesday, because I thought today was good.
Dang, that's hard to hear them talk.
So like,
Now you have to factor out
So I'm making Tuesdays your day?
factor out 12, so
Sounds good.
12, right?
All right, Kimberly.
You can do it from what's
You don't have to do it for a day.
But where you can do x from 324.
What's 324?
And right here.
Oh, no, no, wait, we're not doing this. We're going to add 324 to the other side. Subtract it. We're setting it equal to 0. So first step is we use 324.
Okay.
How do you find it? They're equal to 0.
Don't show up, then you get
I
a
mean, what do you do?
Okay, friends over here.
What do you do?
I want to check grade goals. So Christian, your grade goal 80, and you don't have a mandatory day. Jose, your grade goal,
I think I forgot.
you forgot to write it down. If you maintain a 78 or higher for the semester,
So
you get a
1
C.
minus 12.
I'm sorry, if you maintain a 78 or higher for the
X
6
minus
weeks,
12, put it in the whole
you get a C for the semester. That's very doable.
This 6
That's
weeks?
this 6 weeks.
Really?
All you need to do is maintain a 78 or higher, and you get a C for the semester.
What I do for a B? Or it's not possible?
A B is not possible.
Alright, that's cool too.
Okay, and now the whole wide world is in on our conversation. Awkward.
I'm
Okay, what's your mandatory tutorial day? Monday, Tuesday, or Thursday?
every day except Monday.
Okay, so that sounds like Tuesday and Thursday. Okay, thank you. And Noemi, your goal was 80, and Tuesday is your mandatory day.
I think that, can I change it like every week? Because I'm not sure, but I know I can stay once a
Oh,
week.
that should equal 27.
Okay.
Oh, yeah.
Like I'm saying today.
Okay, so I'm going to keep it on Tuesdays for now.
Put it on my now.
All right.
I'll put it on my now.
And Jonathan, remind me, I still need to get over to your
Oh,
group.
we're supposed to factor 12 on both sides. Whatever you do,
All right.
that's how you have to do it.
Okay, so if all goes well, your derivative is 324 minus 144x plus 12x squared. You set your derivative equal to 0. Now the bummer. The bummer in all of this is that you've got some ugly numbers that you need to work with, and that's just going to shake your confidence a little bit. For the folks with strong number sense skills, you know that there's a common factor here. 12. So I can factor 12 out to get x squared minus 12x plus 27. And that factors nicely as x minus 3 times x minus 9. And you get your internal candidates of 3 and 9. How many guys honestly have 3 and 9 as your candidates? Okay. Folks that didn't get 3 and 9, what's happening?
I forgot I do the x squared minus 12x plus 27. I was trying to like solve it out.
Okie dokie. So a little bit of factoring get in the way. Okay, so the x equals 3 and the x equals 9. Fancy word for this, I just used it. These are your internal candidates. Now, you got to be careful. They're only internal if they are inside your endpoints. And I know over the last couple of days, this class and the last class, determining those endpoints is kind of been a problem. How many guys are kind of in that category? Like, things are going well and then the endpoints, weird things start to happen for you. Okay, the endpoints are helpful and there's a way around the endpoints. But let's have a conversation about the endpoints. Let's see if we can puzzle this out. When we're talking about the endpoints, the question is there a smallest x? Is there a smallest value for x? And usually this has to do with the geometry of the problem. So go back to what x represents. X represents the length of the square that I'm taking out. Is there a smallest value?
3.
0.
Is there a smallest value of what I can take out from each corner?
Yes.
There, right, anything bigger than 0. So what I'm going to say is that x has to be greater than 0. Now here's where I really confused the last class. And I did not mean to, and things went downhill quickly. What's the biggest value? Don't talk to me, talk to your neighbor about this. What's the biggest value? Think about the geometry of this problem. What's the biggest x could be?
There's 3. There's x. There's the height, and there's the length, and there's the width. And x can all be bigger.
But does it have a top of
It
it?
can be infinity for all of them.
Just like
Point
no,
out
it's 18.
Less than 18.
That has to be added, that has to be multiplied by 6 and then added to whatever that is. So it can't.
You're saying it has to be 18, right?
That's
That's what I'm thinking.
18 plus.
Jose,
What?
is it possible that the length of this square is 20 inches?
No.
Was that a no that became a yes or a yes that became a no?
I don't know. I'm not sure.
And you're not sure.
Yeah.
My question for everybody then, could this square that I'm taking out of this corner have a side length of 20?
No.
But the other one has to be
David,
20.
could it have a side length of 20?
No.
Because?
They used to got the other sides. And
Because I've got this other side to worry about over here, and there is a constraint. The constraint is 18. I only have 18 inches of paper to work with. So what's the biggest square I can take out?
18 over 2?
9.
Because at 9 inches, if this guy has a length of 9 inches and this guy has a length of 9 inches, they fill the whole page and the page disappears. The page just becomes 4 squares that you throw away to then make a box. So what I know is that my endpoints is that my x's have to be less than 0, greater than 0, and less than 9. So the real conversation here is, how many internal candidates?
1.
1. 1 is a very good number for an internal candidate. And here's why. It can't be 9. This is your candidate. Now, some of you guys are going to jump too quick. You're going to be like, I got it. It's 3. I'm done. You've not proved it. The proof will involve a number line test, or the second derivative test, or plugging in your endpoints if you have a closed interval. We don't have a closed interval. Let's try the second derivative test, because the second derivative test is the new kid on the block.
So we take v prime.
So second derivative test, not v prime, v double prime. Right, it's the second derivative that you're gonna find.
Oh yeah, we already confirmed that it equals 0.
Well, right, we already know, the reason why we're even looking at 3 is that that's where the first derivative is equal to 0. So the second derivative, what is that, negative 144 minus 24x?
Why did you put that minus 12?
Oh, wait a second.
Yeah, I was confused with that too, isn't it?
There's a plus here, I'm sorry. Plus 24x. Okay. Is everybody okay with the second derivative? Okay. All I care about with the second derivative is what's the sign at my candidate. Negative 144 plus 24 times 3. This is,
Positive.
careful,
No.
24 times 3. I hope you know it's 72, but if you don't, I hope you know that it's more than 60. Negative 144 plus more than 60. Must be negative. Now here's the thing. What's the conclusion?
Since F,
You hope it's a relative max, right? Because I want the maximum volume. But here's the thing. I need to hear two things. At x equals 3, what do we know about v prime?
v prime is greater than 0.
V prime
Or
is
less
V
than
prime.
0. It's equal to 0.
Oh, it equals
Is
0.
equal to 0. That's how the second derivative starts. You have a horizontal tangent line, and there's a second thing. V double prime is
Less than 0.
negative. So horizontal tangent line, and second derivative is negative. You're concave down, right? So the conclusion?
There's a max at x equals
Hey, brother.
V has a, you said max, and that's going to get you in trouble. Relative max at x equals 3. And the problem is that's not enough. What? It's not enough, because if you are really careful with your choice of adjective and what you said was relative max, you know that's not actually what we're looking for. What I want is absolute max. But you know something. You have how many candidates? 1. If that one candidate is a relative max, this is the only thing the graph's able to do. You're only able to have a relative max. The other thing that you know?
It's an absolute.
It's an absolute max. It's the power of 1. So I'd say something like, since x equals 3 is the only, really emphasize that only, relative extrema for 0 less than x less than 9, V has an absolute max at x equals 3. It's a tough proof. These problems are long. There's a lot of writing that you have to do. But this is how we grow our math skills. Now, before you're like, oh, praises, I'm done, I'm out, thank goodness. I don't know that we've actually answered the question. You always want to go back and read this question. Christian, can you read the question for us one more time? Not the whole problem, just the question.
Find the dimensions of the box with the maximum volume.
Find the dimensions of the box. So, go get me the dimensions of the box.
Oh, that's not the answer.
Right, you gotta make sure you're answering their question. The question is, what are the dimensions? By dimensions, I mean, what's the length, what's the width, what's the height?
So plug it in.
Right, I need to know dimensions.
So we take that original 18 minus 2.
Right, so your length is 18 minus 2 times 3, which I think is 12 inches. Your width is 18 minus 2 times 3, 12 inches. And the height, don't fall for it, don't say 12 inches. 3 inches. These are not easy problems. Lots of places to go wrong. Okay. Everybody feeling mostly okay?
I'm not broken.
Good, glad you're not broken. David?
I just want to know, how did you get the second derivative from?
Do you see where v prime says 324 minus 144x plus 12x squared? Take another derivative. All right, one more. Knowing me.
So we can't say that 9 is our endpoint?
9 isn't an endpoint because if you actually took a square of 9 inches on this side and a square of 9 inches on this side, the box would disappear. Okay? All right, let's flip it over. Let's see what you guys can do with this one last optimization problem. If I haven't broken you yet, I will not break you with this one. I hope. It's never my goal to break.
So,
I'm going to give you a couple minutes to play around with this.
I can't believe we actually found an answer. And we only have number 18.
Oh, for real?
Yeah.
All right.
Today after school.
Come on, guys, let's do this.
Curve.
Find the point P on the curve y equals square root of x, which is closer to the point 4, What is the minimal distance?
So I
So that first, that looks like this.
Oh, really?
83 or is that meant to be an 85? Because it's an 85 where you get a B for the semester. 85. And that's Tuesdays are your day. And Jennifer, you are confused.
Well, this is a tough question, guys. I've been broken all way.
And did some analysis here.
I'm not
If you
Just looking at it.
75 or higher, you get a B minus.
Oh, that's the constraint. Y equals square root of x.
If you get an 85 or higher, you maintain, you get a B for the semester. And I think the 85 is the right goal for you.
And the objective
My question is there one of those three
is
that you want to say is your must stay day?
the smallest distance.
Okay, so Jennifer.
Christian, what are you doing? Are you cheating by using the calculator? I'm pretty sure you're not supposed to use the calculator, Christian. I forget.
Can I take it down for Thursday?
Why do you always have pens with different coloring?
Because
You had a
nothing is ever what it seems.
Curve y equals.
Huh?
Which is closer to the point.
Is it from who? So I don't know. All I know is the power is green right now.
It's minimal distance.
Alright, so I think the endpoints are 4 or no. No, it's 4 and 4.
It's like this.
I think we
But this equation, like, it starts at the origin. I mean, this function. So I don't think it can be past the origin.
So we have to find like a point in this that's
on the, a
closest.
point on the line that is closest to 4,
So that
0.
one,
Not on the line, Jose.
Find the point P on the curve.
Thank you.
Oh, curve.
1, 1.
On a curve.
4, 2.
Jose, I promise I listen to other people and not just you. You have such a distinctive voice.
Really?
Yes.
I never noticed.
I hear you all the time.
Oh, well, that's not really distinctive.
There's
now.
one other person that I hear all the time.
Really, who is that?
All the time.
Yeah.
Christian can get away with things. I'm not even sure I know what he sounds
Here
like.
is the graph.
Oh, for real?
4, 2, right?
Mercedes.
Yeah.
I'm actually kind of stuck here. I
Okay.
think we all are.
So
So what have we tried so far?
Now, when you like we're thinking about line triangle P, it's anywhere in this graph.
what's in her?
yeah, that's the same.
I don't know how to start. I don't know the constraint is y equals square root of x. Because it has to be on that curve.
So we're looking for
All right, I want to pull everybody together because I've seen we've all kind of made it to the same point and kind of stopped. Okay, everybody has some version of this graph. You've got the square root of x. You've got the point 4, 0. This is our last optimization problem. I picked it for a reason. What's the objective here?
Smallest distance.
You want smallest distance, right? Smallest distance between point P and this point 4, 0. Martyr, where's point P? There's one thing, and only one thing you know about point P.
Isn't the curve white?
It's on the curve. It is someplace on that curve. What I want to minimize is that distance. I want that distance to be small. How am I going to figure that out? Usually there's some geometry formula, there's something you know that you use for your objective or you use for your constraint. I was hoping that you guys might remember this since you had an exceptional geometry experience. I see you, I'm just ignoring you for a little bit. I want distance. How many of y'all remember the distance formula? Or could find it in your agenda if you were given a couple of seconds?
Oh, really? It's
I
there?
think it is in your agenda.
That is a lie.
Some of you are like, but I can't find my agenda. How could that? Isn't there a section in your agenda where there's like formulas and stuff?
Momentum, oh, it's me.
Let's check this.
Part B.
Is it not there? There's all the trigs.
I don't even know what
Geometry
you're doing.
formulas.
This is due Wednesday.
What a bummer.
Turning in, Jonathan.
See, you lied to us.
We must have bought the cheap one.
You obviously did.
Budget is real.
Okay.
Oh, what a lie that was.
Oh, nah. What are you looking for?
All right. So let me show you a couple of ways you could remember this. Maybe you're that kid.
Oh, it says it in our calculators.
What?
Yes, it has all the equations in here. But that's the song Mr. Kurth taught us. X equals negative V.
No! Don't listen to him!
You got it.
No!
Why did you?
That's the quadratic formula.
Oh my god. I'm gonna say it.
Okay, this guy here, it's x2 minus x1 squared plus y2 minus y1 squared.
Yeah, that's what
You were not singing that song.
You were singing something.
You were singing the quadratic formula song. It was going to end all over 2a, I know. I know. Okay, for those of you, just give me a little, like if this is you. You do not do well with memorizing formulas. Okay, so let's understand them instead. This point P is on the curve. That means it has the coordinates x comma y. I want distance from the point 4 comma 0. I want that distance, but instead what I'm going to do is I'm going to drop a perpendicular line to make a right triangle. The coordinates for this point here, well, let's see if we can figure out those coordinates. I dropped a perpendicular, so it's like right down below the point x comma y. So the thing you know for sure.
4 minus x.
The x coordinate is just x,
yeah.
whatever that value of x is. The y coordinate
0.
is 0. But the reason I dropped this perpendicular was to make a right triangle. Because right triangles, I know stuff. I know Pythagorean theorem. That says a squared plus b squared equals c squared. So how long is this side here? If I'm going from x comma 0 to 4 comma 0,
4 minus x.
4 minus x, you can write it as x minus 4. Either way is going to be okay. How tall?
Why?
Just y. What I want is this distance here. By the Pythagorean theorem, I can say that x minus 4 squared plus y squared equals d squared. Or even better, d is the square root of x minus 4 squared plus y squared. That's your distance formula. Your distance formula, you subtract the x values and square it. You subtract the y values and square it. You add them together and take the square root. That's where this guy comes from. This guy here is your objective function. That's what you want to make as small as you can. Ranbir, what's up?
Can you redo the step from the x minus 4 in parentheses to how you put that into the default?
How do I go from here?
Yeah.
I took the square root of both sides.
D squared.
Because this is d squared. I was a little dirty. I took a square root and I switched the sides at the same time.
Okay.
Is everybody kind of okay getting to here?
Yes.
Okay, here's what I really care about. What do you do next? Talk to somebody else about it. What's your plan?
Now we have to.
You need this.
Yeah. But we, how do you get that first? The one above the D?
We're supposed to do
X minus 4 squared.
point?
He picked a random point and just gave it to you.
Right. I don't know exactly where P is, but it has to be on the curve. That's what I know for sure. All right, Kimberly, what did your group talk about? What's your strategy from here? No idea. You need a constraint because there's two variables over here. Because what we really want to do to move forward, Jonathan, what do you really want to do to move forward?
Solve for one.
Well, you want to solve for one variable, but to move forward, you have to take a derivative, right?
Yeah.
You have to set the derivative, all the stuff. And the block is you have two variables. So there must be a constraint somewhere. There has to be something that relates these variables together. What's the constraint? It's showing up differently than anything we've ever seen before. What is the constraint?
4 and 2.
Can you formulate it?
There's something that relates the x and the y together. Adriana, what do you know?
Is it the 0.4,
Well, the point 4, 0 unfortunately doesn't have x in it and it doesn't have y in it. I'm looking for an equation that relates the x and the y variable together. David, what do you see?
A right triangle is like how it's 1, 2, vertical 3. So it's the lengthwise is 2 of the.
Okay, hold on. You're thinking about there's a special right triangle where that happens.
30, 69.
Like the 30, 69 here, maybe the 45, 45. There's no guarantees about that.
Oh.
The constraint is showing up in a different place than what we've seen before. Noemi, do you see it?
The y equals square root of x?
Y equals the square root of x. The point P that we're talking about has to be on the curve. It can't be up here, it can't be over here, it can't be down in this quadrant. The constraint is here. It's that your y value has to be equal to the square root of x. I don't think, clearly, nobody saw that. This is not the kind of problem we've done before. David sees it now. Or saw it before, but was quiet. Okay.
Can you explain?
The point that we're talking about has to be on the curve.
Yeah.
That is your constraint. That your y value is equal to the square root of x. That point P has to obey this relationship. So that means that my distance formula can now be rewritten as x minus 4 squared plus the square root of x, the whole thing squared. Or even better, square root of x minus 4 squared plus x. Good news. One variable. Only one variable in the objective function. Why is this good news?
Because now you can find a derivative.
Now you can find the derivative. Now you can,
B double prime. D double prime.
once you find the derivative, set it equal to 0. Figure out where it's undefined. Do all the things that we normally do. And so this is where I want to interrupt with a new idea. Okay, here's the new idea. My goal is to make this value here small, right? As small as I possibly can make it. Instead of focusing on the square root of all the stuff, I'm just going to focus on the stuff underneath the square root sign. I'm going to define a new objective function called big D.
Big D.
I don't mean that big D.
Oh.
In the DeRozier house, when you have big D, it means that stuff's coming out and it's not good.
I'm Big D.
No. Diarrhea. That's the pleasant way to say that things aren't going. You're like, I got the big D. This is a different big D.
Diarrhea.
This big D is what's underneath the radical. And here's the new idea. If D is really, really small, then guess what? So is the square root. So if you want to know where this is the smallest it can be, make this guy the smallest it can be. If you wanted to know where this guy underneath the square, where the square root of the stuff is going to be as big as it can be, make this really, really big. The advantage of this new objective function, think about your derivative life.
Just square it at the end?
Well, you could do the algebra and take a derivative, but think about your derivative life. That's a really easy derivative to find, right?
Oh, yeah.
This should be a very easy derivative for us to find.
Just that.
A very easy problem to set equal to 0,
Yeah.
to solve, to finish off, I know this is the new idea. This is the thing that nobody was expecting. We've not done it before. See what you can do from here. I'll give you a couple minutes.
So the new idea is ignoring the square root.
Is we're going to ignore the square root, but I'm defining a new objective function. Because, hold on. Because what I'm saying is if big D is really small, then so is the square root of the stuff.
Yeah.
But if big D is really big, so is the square root of the stuff. So I'm just focusing on what's underneath the radical sign to say, let me make this as small as it can be.
So do we square that now?
Well, you want to find the derivative. You want to set the derivative equal to 0.
Oh, okay, yeah.
Know what I mean? Are you okay?
Yeah.
All right. Wrong beer.
Do you think we should always like make it into the most simplest form?
Totally your choice. I mean, there are going to be times where it makes life better.
So we're setting it right now, or we're setting it?
And delete.
Minus.
So it'll be x squared minus 2.
And 2 times x
Are you
minus
still
4
able to make that poster for me?
plus 1.
Okay. Like tomorrow? Okay.
Yeah, it was good.
So it's 2x minus 9. I got 2x minus 9, dude.
Oh, I'm seeing some sloppy notation.
Uh-oh.
So I got the big D equals x squared minus 9x plus 16. And now I'm gonna take the derivative.
Not x squared minus
The
9x
derivative
plus
of
16.
x is
It's
1.
not?
This is still big D.
Oh, it's a negative. Oh, it's a
It's 2x.
Is it 2x minus 9? The derivative of that?
So,
7.
Did you solve
you're gonna make
that?
them
I'm curious, is pretty much everybody expanding this?
Yeah.
Multiplying it out?
No.
Okay, you're taking the derivative using the chain rule?
Yeah.
Okay, so I'm going to go with the chain rule, which means that d prime, I've got stuff squared. So 2 times x minus 4 times the derivative of the stuff plus 1. So d prime is 2x minus 8 plus 1. D prime is 2x minus 7. For my people that are expanding, you're going to get x squared minus 8x plus 16 plus x. So x squared minus 7x plus 16, and d prime is 2x minus 7. Same thing. Same thing. Martier, what's your next move? You found the derivative. Why? Why did we find the derivative? What are you trying to do? So d prime equals 0. So 2x minus 7 is equal to 0. That should mean x equals 7 over 2. Not done. So not done. So not done. Jennifer, why are we not done?
Because you have to find where the small d is equal to where the function does not exist.
Well, okay, good. So where does this not exist?
No. There's no.
There's no denominator here, so I'm not worried about not existing.
Continue.
It's my only candidate. Hold on, Adriana, I see you. You've got an internal candidate at x equals 7 over 2. Any other internal candidates? Then that's a good thing. Why? Who can tell me why? Why is it a good thing that you have one internal candidate? I see 1, I see 2, I see 3, I see 4. David, why is it a good thing that there's one internal candidate?
It's a good thing because that means even if when you find the relative max for it, it's still gonna be the absolute max.
If you can show me that this is a relative max, you're also showing me for free absolute max. If you find out this is relative min, then for free, it's an absolute min.
Yeah.
So all you need to do is tell me relative min or relative max. But you have to prove it. You have to prove it.
Greater than 0.
Let's go for the second derivative test. So find d double prime. D double prime is 2. So
Are you
let's
taking the big or small? Oh,
big, big. So I'll start you off with the conclusion. At x equals 7 over 2. What do we know?
There is relative extremum.
There's 2 things. You got to get me both things.
The first derivative.
The first derivative
Equals 0.
equals 0, and the second thing,
Positive.
D double prime is 1.
d double prime is positive. First derivative is 0, horizontal tangent line. Second derivative is positive. Horizontal tangent line. derivative, second derivative positive. So the conclusion?
It's a min.
Therefore,
Relative min.
a relative min. This is a good thing since I'm looking for absolute min. But you can't stop here. This is the mistake the BC kids made all the time. They were like, oh, I'm done. I'm done. All you proved was relative min. You gotta go one more step. Jonathan, what's the one more step?
Say it's an absolute min.
Okay, and why are we gonna say it's an absolute min?
Since there's one, since x equals 7 over 2.
Since x equals 7 over 2 is the
Only underline it.
only, I mean, you don't have to underline it. The only relative extrema, you don't get points for underlining, is the only relative extrema, then this must be an absolute minimum. And that almost finishes the problem. Almost. This is some beautiful stuff here. If you're even 80% with me, this is some beautiful stuff that we're doing. But you're not done. Abraham, do you know why we're not done?
Yeah, so like refers to the exact point.
Because what?
So like I think we're because at the point
Back to the question.
say that it's a mean
Go back to the question. What's the question? The first thing they say? Find the point P. Where's point P? You have to answer that question. Where's point? Anthony, where are you going? Where are you going? That's what that said? Miguel to Mr. D. No, that was last period.
Okay.
Romby or Noemi, Anthony, not Jenny. Sale at 4. You guys are getting sold?
Yeah.
Oh,
that's
man,
a
I put all this work into you and you guys are getting sold? All right, let's wrap it up. Point P, where's point P? What are the coordinates for point P? 7 over 2 is the x value. Where's the y value?
We have to plug it into the y is equal to the square root of x.
Right, so if x equals square root of 7 over 2, then y is square root of 7 over 2.
Get it.
What's the distance?
Plug it into D.
The distance is going to be then square root of 7 over 2 minus 4 squared plus, what, 7 over 2? And if it's multiple choice, simplify. If it's free response,
Either one.
don't. But let's see if we can simplify. 7 over 2 minus 4. Impress me with your fraction skills. 7 over 2 minus 4 is the same thing as 7 over 2 minus 8
Negative
over
one.
2,
Negative 1 over 2.
which means negative a half. Negative a half, square
Negative 1 for 1 4.
it. Square it the right way. Negative a half times negative a half is
1 4.
1/4. 1/4 plus 7 halves.
15 over 4.
1/4, 7 halves. This means 14 over 4, so this must be
The distance.
square root of 15 over 4.
Yeah.
Okay. These were not meant to be easy problems by any stretch of the imagination. Tonight, I've already sent you guys the solutions to all the optimization problems we've done from the last 4 days. The only homework that you need to do between now and tomorrow are the corrections to the multiple choice. You guys have hopefully made some good progress on that already. Okay, for those of you that are going to stay with me after school today for tutorials, I think the right thing to do, there are some of those options that I gave you guys yesterday to work on. There were like 3 problems. I said, you know, pick any of those. I'd work through those and make sure that you know what you're doing. Okay. All right, Jose, you can close the cover.
Stop it first.
If you close the cover, it'll stop.